Unit 6C, Linear Regression. Regression lines and regression equations. When there is a significant linear correlation between two variables, then we can use a regression line and a regression equation to show the nature of that relationship. So the correlation coefficient shows the strength of the relationship, and the regression line and regression equation show the nature of the relationship. A regression line is sometimes called the line of best fit when we have a scattergram we look for a straight line that is closest to all these points. So sometimes it's useful to make the oval around the points and draw the major diameter of that oval, and that line is pretty close to the best fit regression line. Here's an example of a scattergram where we have a strong positive relationship, positive correlation between the variables. Something like this would be our regression line. Notice that the regression line would have a positive slope. Positive slope suggests positive correlation. Same thing in this case. The regression line shown in the picture has a positive slope, indicating we have a positive correlation between the two variables. Here's a case where the slope of this line is negative because the line is going downhill. So negative slope for the regression line illustrates a negative correlation between the two variables. The linear regression equation is usually written in the form y equals ax plus b, or you can write it in the form y equals b plus ax. Generally, we're going to use this first one, where x is the explanatory variable, y is the response variable, a is the slope of the line, and b is the y-intercept. We can find the regression equation by hand in a similar manner to the way we found the correlation coefficient. It's a rather tedious process. Here we're going to find the regression equation using the TI-84 for the data in the chart below. We enter the data into L1 and L2. We press second catalog, navigate down to diagnostic on, hit enter twice, then press stat, calculate, number 4, the linear regression, hit enter, make sure L1 is in X list and L2 is in Y list, leave blank frequency list and store, go down to calculate and press enter, and you'll see that we have y equals ax plus b is the general form, and all we need know is what A and B are, and that tells you, the calculator tells you A is 1.5 and B is 1.83, roughly. So that is the regression equation. Very simple to do on the calculator. By the way, this also gives you the correlation coefficient, 0.98. So there's our regression equation. For the previous example, we want to use the regression line and the regression equation to do two things. Predict the value of y, the response variable, when the explanatory variable has a value of 1.3. And also we want to determine the marginal change in y. We'll do this two ways. First, we'll just use the line to do this. X is 1.3. 1.3 is about here. So if we proceed vertically up to the line, and then we're going to go over to the y-axis, the value of y would be this point here, which is going to be 3 point something. Well, it's pretty hard to estimate. It's more than 3.5, so maybe it's 3.6, 3.7, something like that. You could call it 3.7. 3.7 would be our estimate for the value of y. The other half of the question says find the marginal change in y for a change of 1 in the x direction. So the marginal change means find the change in y when x changes by 1. So pick any point you'd like on the line. So maybe we'll pick this point right here. We'll pick that point and we'll go one box in the x direction, which will bring us to the middle of this box right there. That's 1. And now the marginal change in y would be this distance from here up to about there. So that's one box. Now how many boxes is this? This would be one box plus about a half a box. So this would be 1.5. So the marginal change would be 1.5. When x changes by 1, y changes by 1.5. We could answer the same questions by using just the regression equation. When x is 1.3, put 1.3 into the equation. So y equals 1.5 times 1.3 is 1.95. And then add 1.95 and 1.83, you get 3.78. That's about what we had before, but this is a little more exact. And then to get the marginal change, the marginal change would simply be the slope of the line, 1.5. So the slope of the line gives you the value of the marginal change. And the slope of the line is just the coefficient of x in our regression equation. But after all, this is y equals mx plus b. The marginal change is just m. That's the end of Unit 6C.